the level that we need to be at. So everything that's of a lower number, which is everything below it, ideally should be completed by then. From now on, I'm going to require that we do complete a lab, a high number lab, and that assignment will be due before the physical labs. Not this week, because I'm behind the curve. I forgot to publish incomplete module 2. So that got published yesterday. So the 27th, which is Friday, right, that's Friday. Yeah. That's when I want this one to be complete, okay? But just realize for subsequent physical labs, look at the labs with the lower number, and I would like those ones to be completed. So since 438 is the one that's due, that means that this lab, these 3 labs, will be worth extra credit. If you find the solution to the challenge lab, okay, it's a challenge because you're not given the instructions to find the problem. You have to troubleshoot in order to get to that solution, okay? So these 2 will show you the skills that you need. This will just be a physical version of that, so you don't need to do this one. You can just do that one and then do this one. Okay. So this should be all you see, correct? Over here? Okay, good. All right. How do we use VLANs? What are they? So we did talk about VLANs all the way back in 101. So what they are should be a refresh. A multi-switched environment, okay, which is most environments. Any enterprise environment is going to be multi-switched. Okay, they're going to have more than 48 computers, definitely, or 48 devices that need internet connectivity. Okay, access points, door locks. Okay, those sometimes need Ethernet connectivity. Sometimes that operates in half duplex, and that's a separate network, a complete standalone, non-routed, and it could be a VLAN. Okay, so instead of purchasing 15 different switches for the 15 different networks you need, get a switch that supports VLANs, which is pretty much any switch that's worth spending money on for business. You can go to Walmart, Best Buy, buy one of those pocket switches with 4 or 5 ports on it. That's fine for home, okay? Just to give, some more ports to your computers and TVs at home. We're going to talk about how to configure these things. So again, we know a little bit about VLAN configuration already, but we're going to go in more in depth to it. So we should be aware of what a trunk port is. So anyone confident they can explain in their own words what a trunk port is? Any volunteers? Yes.
Where computer 1 wants to talk to the other side, it's where it will go between the switches. Or
between the switches, yes, that's yes, between switches. Trunk ports are found between 2 switches. Whatever VLAN the PCs are on these switches, connected to these switches. Okay. If you want that same VLAN over here to be over here too, then you need to connect those 2 switches via a trunk port. Yes. And then a protocol, a Cisco proprietary protocol that can have this happen automatically or dynamically is DTP. DTP, you do have to know what you're doing because you can kind of screw things up. All right. So here's your graphic for VLANs. We have multiple floors, first, second, and third floor, and each floor has its own switch. So they're physically separate switches. But we've got some computers on each floor that are a part of the same network. Okay, so answer this to yourself. If this PC sends a broadcast, will it show up on this PC? No, it won't. Will it show up on this PC?
Yes.
Yes, it will. Okay. This is a single broadcast domain. Okay. A network is a broadcast domain. Now, I don't want you to be confused on a physical network. So I'm looking at a switch. That's a network, right? But what about an IP network? 192.168.1.0/24. That's an IP network. Can you have multiple IP networks on the same physical network? Yeah, absolutely. There's nothing stopping you. That's, you can have a million logical things existing on the same physical thing. Absolutely. So if I give this computer an IP address in this IP network, but then I give that computer an IP address in this IP network, will they be able to send each other pings? No, they won't. Okay, they'll have different IP addresses. Now, they're still gonna be able to broadcast to each other though. Okay. This guy's gonna hear, they're gonna hear each other broadcasting for these IPs that are outside of its own IP network. Okay. Also, don't get confused with subnets in VLANs. There's a slide in here that if, this happens to a lot of students, myself included. You'll think that VLANs, or when you need to subnet, you have to have VLANs. That's not true. You can subnet, but have every device be on VLAN 1. Again, they'll hear each other's broadcasts, but they're not going to be able to route or ping each other without the presence of a router. But most of the time we do put our subnets on VLANs. Because the whole, we don't want them to see those broadcasts, those layer 2 broadcasts, and waste traffic. And remember your reasons for doing VLANs: increase security, decrease broadcast domains. We'll talk about all that stuff. I'm kind of just getting ahead of myself here. All right. Yep, segmentation of these groups on the same switches. So again, you can put some IP rules on this network so that this network cannot talk to that network, or vice versa, maybe. And that results in better segmentation and management, more organization. It makes IT's lives easier. Okay. If you had a single network for every computer in an enterprise, remember that would be like this building being glass, where we could see everything that's going on. It'd be incredibly distracting. Or if we could hear other classes going on at the same time. Now this is an evening class, so kind of by ourselves up here, but you get the point. Broadcasts, multicasts, and unicasts are isolated to the VLAN. Yes. Okay. Yeah, when you're using VLANs, layer 2 and layer 3 broadcasts are contained. Okay. All right. Each VLAN should definitely have its own unique range of IP addressing. This is where subnetting comes into play. So they go hand in hand, but they're not mutually exclusive. Okay, you don't need one to have the other. Okay. So yes, IP network. Correct. Yes, Gary. But remember that there is layer 2 broadcasting and then there's layer 3 broadcasting. A layer 2 broadcast is all Fs in the frame header. The switches will distribute that. Okay, but IP broadcasts are a bit different. And it depends more on, your logical addressing rather than your physical layout. Okay. Any questions so far? about VLANs.
Yeah, you probably explained it and I missed it, but the graphic, how it has those vertical blocks, but the switches are going horizontal?
Yeah,
Yeah, like,
so this represents a single network that these computers are in virtually, even though physically they're all connected to these switches.
right, so there's each one of those three computers vertically has a switch. The
Um,
corresponding switch to the left?
right, okay, so I will say this, it's not like we're doing a bus network situation here where,
Right.
right, each PC has its own direct link, its own Ethernet cable back to the switch, and its own independent switch port. Okay,
Okay, so the graphic's a
yeah,
little misleading, right?
yes, that
Okay.
by itself is misleading. This cable is really just to represent that they're all physically connected to this switch.
Right, but on different ports.
Right. They're
Right,
connected
okay.
to different physical ports, which are configured for those respective VLANs.
Gotcha, thank you.
No problem. All right. So again, these are your benefits. Smaller broadcast domains, improved security. We can put rules between these networks. IT efficiency. Yeah, absolutely. You know, by the end of your first week at like a help desk IT job, hopefully you'll interface with VLANs a little bit. You'll completely understand why it's awesome and why life's so much easier. Okay. You know, again, imagine a mall was just a warehouse. Every shop just set up their table. There was no walls. Well, that's called a convention center. And it's very loud and busy and not a place that you want to go back to every day. So malls have shops, you know, individual shops where they don't have to pay attention to each other. Reduce cost, yes. We're not buying, you know, in this previous graphic, we would have had to have a switch on each floor for each VLAN. So that's 9 switches. No, we're not going to do that. That's not in the budget. We're going to buy the slightly more expensive switch that supports VLANs. And small broadcast domains results in better performance. So these are kind of the same thing, but it's worth separating. And finally, simpler management. Okay. All right. Types of VLANs. So the first type of VLAN that we're going to learn about is the default VLAN. The default VLAN is, by default, VLAN 1. VLAN 1 is every type of VLAN to begin with, okay? It's the default native VLAN. It's the default management VLAN. I believe it is the default voice VLAN when you just power up the switch. And we can verify this. You can verify what the ports are in, what VLAN the ports are in by issuing this command. Show VLAN brief. These other VLANs, they are there by default for legacy reasons. FDDI, token ring, FDDI net, and token ring net. These are all legacy stuff, so, and you can't delete those. You cannot delete VLAN 1, and that's not possible. Cisco switches, the ports have to be in a VLAN. So VLAN 1 by default. All right. So the data VLAN, that is what you can call a regular VLAN. That's where the host devices, that's where the endpoints will reside. That's where they will live. User-generated traffic. So you could also call this the edge. Okay, the edge is where the users are. The native VLAN. The native VLAN, its job is it's basically like, if there's no place else to go, it will go here.
Does the data VLAN have voice?
No, voice is a separate type of VLAN. We'll talk about that one right there. So yes, data VLAN. So for instance, just to give you an example, the computers in the desks here in the classroom, this data VLAN is VLAN 12. Okay, VLAN 12. That is in the beginning of the YC network. That was the VLAN given to CNT. And that was the only VLAN we used. We've since branched out, and because we subnetted from a flat network, we decided to, yeah, let's do some VLANs. Okay, because subnetting without doing VLANs is, it's not lazy, it's just incomplete, right? It's kind of like you built a foundation in a frame and there's a roof, so it'll stop you from getting rained on, but it won't stop the wind, you know? All right, but yes, the native VLAN carries traffic when something isn't tagged. So if something's not tagged, it will get tagged for the native VLAN. But the native VLAN also carries tagged traffic. Traffic becomes tagged once it comes, the data comes in on an access port. Okay, let that sink in a little bit. The computer is not the one that says, I'm in VLAN 12. The switch says the traffic that's coming in is getting put inside of VLAN 12 from this port. Okay. You can have 48 ports assigned to 48 different VLANs. You have 48 different networks. How many router interfaces are you going to need in that example? 48 different networks. One router interface, physical, not virtual.
Oh.
Or virtual, not physical. You're right. Physically, you could do that physically with one cable. That would be a trunk. 48 router interface ports. 48. You have 48 networks. You need 48 router IP addresses and interfaces. Okay. We're going to talk about sub interfaces and stuff like that. That's how you can get a single physical cable to be, well, it is a trunk, and then that connects to the router. And then the sub interfaces are what's inside of all those different VLANs. And then from there, the router routes between those sub interfaces. That's legacy stuff. Okay, that's why 3.4.8 is routing with a layer 3 switch. It's actually really cool. When I took this class, layer 3 switching was a thing for a long time, many years, but it was not in the curriculum. So the fact that you guys are seeing layer 3 switching is very real world. Okay? Router on a stick is just not the way to go anymore. It's like hubs. It's only useful now to teach concepts. 802.1q. What's 802? What the heck is 802?
Wireless?
It's a lot of things. I hear wireless. It
Channel 11.
channel 11. 802.11 is Wi-Fi. 802.1q VLANs. 2.3 is everything Ethernet. And all that stuff, 100 base T, 10 base T. IEEE 802. That's the project. It's the 802 project. It's a standard, okay? So when you see 802 dot something, it's a standard. We're talking about a standard. You can look this up. And you can see exactly, what the manufacturers, Cisco, Juniper, Dell, HP, they're all looking to this standard to develop their implementation of VLANs. So anyways, this means trunking, VLANs, and all that stuff. Yeah. All frames are tagged if they go through a trunk except for the native VLAN. Data should not originate on the native VLAN, okay? All data should be tagged. If it's not tagged, it ends up on the native VLAN, and there's some security issues with that, performance issues. And the user's probably gonna be looking at their computer offline saying, what the heck? Okay. All right, the management VLAN, this should not be connected to the internet, or should it be connected to the internet? Shouldn't. Well, it depends on what you're trying to do. Are you trying to manage these switches from the comfort of your house? Well, then maybe connect it to the internet, sure. There's a couple ways you can do it. You can keep it offline and then VPN and then route between the VPN and the private network. Yeah.
So doesn't that create a bigger security risk if you connect it to the internet though?
Yes, it would increase your risk. Yep. Yep. So ideally, the most secure thing you can do is what's called an out-of-band management network. And if you're totally secure, you don't even mess with VLANs because, as we're gonna learn, you can hop between VLANs. It'd be like me teleporting through this wall into another room. There's a super secret meeting going on in there. What if I teleported in there? Crash the party, that's not good. But if this building, you know, was out in the middle of a field with a moat around it, I'm not gonna get in. It's gonna be very difficult to get in. Where there's a will, there's a way. But anyways, we're gonna learn how to mitigate VLAN vulnerabilities. Okay. The voice VLAN. The voice VLAN with other vendors, they might do this differently. Okay, the voice VLAN is just a special VLAN. It's a regular VLAN that's pre-configured with things like assured bandwidth. So a minimum amount of open pipe is always going to be there when someone starts a call. QoS priority. What's QoS stand for?
Quality of service.
Quality of service, yes. Quality of service. Ability to avoid congestion and maintain latency less than 150 milliseconds. Yep. 150 seconds is, how much of a second is that? 10th and 8th? Well, it's whatever, a 15th of 100. No, because you could reduce that. I'm not good with fractions. Okay, but that's about, you know, a human is not really gonna notice that. It's more than a 10th of a second. But in conversation, a 10th of a second is not that. That's 100 milliseconds, not that. For other things like video conferencing, about the same. You don't want any more than 150. Otherwise, it becomes, you know, it's like you're talking to a mime or something.
Gaming on 150 would be tragic.
Gaming on 150?
Would be tragic, yeah.
I wouldn't say it'd be tragic. Tragic would be having no internet connection.
True.
That's what I remind a lot of students these days. You know, back in my day, I never had to deal with kilobit speeds, you know, 144 kilobit modems, never had to deal with that. But I always remind people, internet is better than no internet. Okay, kind of tend to forget that. Yes, William, 2002. No, it was 1982. You're off by 20 years. 802 was 1980. 2 is February. Yeah, so they started the project in February of 1980. Okay. Anyways, the voice VLAN can do special things like interface with Cisco VoIP phones really well. Cisco VoIP phones have this cool thing where There's two ports. One port you connect back to the access port on the switch, and then the other one goes to the PC. So one physical cable needs to be ran to the desk. Okay, only one cable. Typically, this is gonna be PoE as well, power over Ethernet, because this phone needs some power as well. Yeah,
So with that, it would be one VLAN and it would operate both the phone and the,
two VLANs.
okay, so it's still technically two,
Two VLANs. So technically, this is a trunk.
but only one line,
I'm sorry?
but only one physical line.
Only one physical line, right? This is a special kind of trunk, I will say right now. So the PC is gonna be in a data VLAN, and then the phone is in the voice VLAN, but they go back to the same port. And yes, so when you do this with a phone, there's some extra commands that you need to put here. This is starting to fall by the wayside, you know, with the prevalence of smartphones and things like that, but there are still a lot of businesses out there where they're not paying for a smartphone for their employee to take home. That's too expensive, too much of a risk. So they have desk phones still. Pick up the phone, make a call, put it down. Okay? Simple as that. VoIP. VoIP is a skill set that you're gonna find on some job postings. Okay, you need to be skilled in VoIP. Alright. So this is gonna be an interesting research for you to do. You're gonna see who hears the broadcast in some sort of topology. What you see physically is not how it behaves virtually. Yeah, virtually in the VLANs. All right.
Is there any way that the
VLANs in a
camera could be
multi-switched
moved to the side just a little bit? It's a little cut off.
I can't. If I try to move the camera, here, I'll show you.
We fixed it.
Oh,
We've been fixing that.
well. It's
That's all right.
still not very granular.
Hey, that's better.
More time. It's a lot better. I will say that it's a lot better. Is it frozen? No, it's not. All right, we'll go with that. All right. VLANs in a multi-switched environment. So we'll get through a few slides right here, and then we'll take a break. We're on 23 right now. We're making pretty good progress. We've got about 90 slides to get through tonight. All right. Well, first off, is this a trunk? Oh, that's not gonna be a trunk. Is this gonna be a trunk?
No.
About this?
That is, yeah.
That will be a trunk, especially since it shows us VLAN 1 or 10, 20, and 30. So how many trunk links are in this topology? Two, there are two between the three switches. We could have a redundant link between these two. STP will do its thing and shut that off. STP, I will say now, because that's the next chapter. STP gets interesting when VLANs are involved. There's multiple versions of STP and you need to know the characteristics of those. Okay. It's more, you know, it's this the Cisco proprietary and then everybody else. More of that. Yep. By default, supports all VLANs. Yep. I will say that's not the behavior on all Cisco switches. Some Cisco switches, you have to allow certain VLAN. The enterprise ones, yeah, that would be that by default, it's just gonna allow everything. All right. All right. Without VLANs, all devices would hear everything. Everything. Right, so without VLANs, then all of these broadcasts are eventually gonna go here, 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 and all three of them be sent to all three PCs. Okay, we don't want that to happen. If we go ahead and put these in VLANs, then according to this topology, the only device that's gonna see this broadcast will be PC1 or PC2? PC1. They're both in VLAN 10. The broadcast will travel that way. Okay. Sometimes that doesn't happen. That means something's wrong. It means you gotta troubleshoot. One of the first things you can do is check. I would go to switch 1, and then I would look at the VLAN settings for this port and that port. And I would check to make sure that VLAN 10 is allowed in this direction and that direction. And I would check that switch and that switch.
Quick question.
Yeah.
Make sure I'm tracking this right. Each of those ports has to be configured to allow each VLAN, correct?
So trunk ports or access ports? Trunk ports or access ports? Trunk ports by default will allow every single VLAN.
Oh, right.
Okay.
Okay, so it's only so in this case right here, only 2 and 3 would have to have their ports.
Set on. So
Well, or that one too.
This port-
Only the switches that were connected to the end devices would have to have the ports designated.
correct,
Okay,
correct. That's called an access port. So we have 1, 2, 3, 4 access ports. And then we have a total of 1, 2, 3, 4 trunk ports. 4 access links, 2 trunk links. All right. Good question. Yes. Ask for that clarification. You're not going to be the only student with that question. Oops. All right. Few more slides and we'll take a break. The tag. When something is in a VLAN, really what that means is the frame header is tagged as such. That's literally what's going on. So again, here's your full thing. Right, frame, segment, oh, there's a packet in there, and then your data. No, frame, packet, segment, packet, frame, segment, packet, frame. All right, segment, packet, frame. Okay, but within the frame, you have this area and this area, what's inside of that area are these, you need to know these fields. You do need to know these fields. Okay. So type 2 bytes. How many bits are in this? 16 bits,
16.
correct. 16 bits. Yeah, so you can have, different types of tagging. User priority. I'm drawing a blank on that one. Point is you got to read about these, okay? They're going to be asking you questions in the exams about this tag versus that tag. VLAN ID, this is the number that is your VLAN number. Okay. 2 to the 12th, 4096. There's only a total of 4096 VLANs possible. The standard range of VLANs is everything below 1023, I believe. Yes,
CS, frame check.
correct, yes. Frame check sequence. frame check sequence contains the CRC. All right, let's stop there and we'll come back. Let's take less than 7 minutes, or let's take less than 10 minutes. So let's come back in 7 minutes. Right? 23. Yes, so question?
How many more, how many more slides by chance?
We are on 27 of 64. But a lot of what's in the end, like these packet tracer, I'm skipping past those. Summary and new terms. So realistically, we're about halfway.
Was it?
I have everything.
That I knew.
except I do not know how to read.
No, I was looking at it and I go to your MLS.
Okay, I'm at MLS.
It is a trunk.
So it would be considered a trunk, even though it's connected to the hub.
Right. In again, for legacy reasons, this is what you would do. You would. The hub facing port. You would make it a trunk. Yeah. So that the traffic ends up on the native VLAN and then you can handle it from there, but that's not best practice anymore.
So basically, PC1 is just gonna be hearing everything.
They're not gonna be hearing everything. They're kind of in the ether, if you will. The native VLAN is the one ether. Yeah, you can route in and out of it. You're not supposed to. It's supposed to carry tagged frames to and from their destinations. Whether that's a router or a switch that packet is ultimately the end device, that's where that packet's going, is to that end device. Yep, so if a device was here in VLAN 3, this port is an access port, VLAN 3. So the data gets sent, it's untagged, gets here, it's tagged. And then according to the MAC table of that VLAN, it will then try to send it out of the correct port wherever that destination MAC address is, that VLAN. But, when it's being transported in the trunk link, that frame, there could be a VLAN 2 frame right after that. VLAN 2, VLAN 3, VLAN 2. That traffic won't interact with each other. They won't be able to see each other. Without the presence of a router, a device here will not be able to ping a device here. All right. Yeah, it is possible, but this will create a mismatch. And if there's a mismatch, so if there's a mismatch on this link and the router is right here, PC1 is offline. It's offline. It won't be able to, that traffic won't end up at the router. I did forget to hit record, so my beginning talking was not captured there, but we're recording now. All right. The VoIP phone, so I talked about 2 ports, but it is 3 technically. So this is, inside the switch or inside the phone contains a little switching component. Remember what CDP is? What CDP stand for? Cisco Discovery Protocol. So is it proprietary? Very. It says Cisco in the name. Yes, it's proprietary. Okay. All right. Yeah, so CDP is used more than just a discovery protocol. It actually manages some of this communication between the VoIP phone and the switch. Yep, so the phone via this switch, so this is, you know, your voice waves come through, they're tagged in the voice, and then it's sent that way. You're not gonna send it that way. And then this is an access port. Okay, so that's why I say that this is a trunk, but it's a special, it's not a trunk. It's a special kind of trunkish thing, okay? Trunkish. Okay, yeah, and yeah, depends on what kind of phone you're working with. All right. So what's gonna have, what should be prioritized, the access VLAN or the voice VLAN? What's gonna be prioritized in, you know, what are you gonna configure the class of service? You're gonna configure it such that voice is going to receive priority over the access. Okay. We want to hear our phone conversation. First and foremost, Windows updates can take its time. Okay. All right. So if you do have a switch port that is configured to work with a VoIP phone, then you're going to be able to verify that it is a member of both of these VLANs. If you do show interfaces, switch port. Okay, switch port. This will show you, it won't include all of that other stuff about protocols and things like that. You're just focusing on really 802.q configurations. This is all 802.q stuff. Remember, there's a pretty big difference between show interface and show interfaces. All right. Investigate a VLAN implementation, observe broadcast traffic. So again, that's building on the who hears the broadcast one from before. So again, a good idea, especially if you're struggling to stay awake, open up Packet Tracer, throw down a basic switch, fast forward time, so it boots up, access CLI, and issue these commands. Just to, you know, it's a very good idea to understand what a switch looks like in its native default configuration. So doing all of these show commands in a blank, fresh switch will help you, you know, conjugate what you did, what you actually configured. And then you do subsequent show commands after that. All right. So similar to port numbers, VLANs have ranges. The first one's about 1,000. And then these are these reserved legacy VLANs that are going to be wasted probably until the end of time. And then you've got the rest of them, the extended ones. So yeah, these didn't always exist. Once upon a time, you only had 1,004 VLANs to choose from. Now we have more. All right. So, yep, this is, you know, we should know this. Conft VLAN number, and then once you get this prompt, you're configuring an interface. Interface that, well, no, you're not. Sorry. If you did interface VLAN 1, that's the interface. And then it would say config INF. No, but this is VLAN configuration mode where you can set the name and there's a bunch more stuff you can do in here. All right, so what's going on here? If the student PC is going to be in VLAN 20, we need to create VLAN 20 first and then name it. You don't have to name it. By default, the name would be this. This is just a friendly name. And you should do this. This is documentation. The best kind of documentation, my opinion. The minimum amount of documentation you should do is descriptions. All right. Once it's created, yep, you got to create it first before you can assign it. And then you go into okay, that port, you can do the range command as well here. Interface range. So you get the first 10 ports, those are going to be this VLAN, the last 10 ports are going to be this VLAN. And then unused ports, it's standard practice to put those in a special VLAN that gets shut off. Sometimes it's called the parking lot VLAN. Okay. It's a good idea to buy a switch that has more ports than you're going to need. Okay. The cost difference between a 16 port and a 48 port is typically less than double. So you can get 3 times the ports for less than double the price. Is the way to go. What do you do with all those extra ports? That's a liability. Someone could just, especially in our case, walk up to our switch and plug right in. And depending on which port they plug into, they're going to go into one of many different VLANs. Important VLANs where, you know, VLab lives in our domain servers and all that important stuff. We're going to learn how you can take care of that and not have to shut those things off. That's switch port security. We'll get there later. But yeah, so if you want an end device to be in a VLAN, you need to assign that port to a VLAN. Before you can assign it a VLAN, you need to put it into access mode. So there's 2 modes, kind of been talking about it already. Trunk mode and access mode. Okay, if it's access mode, the frames will be tagged. If it's in trunk mode, the frames will not be tagged unless they come in untagged. If they come in untagged, they go to the native. They shouldn't be coming in tagged though. That's why we do this, access mode. This is what's tagging the traffic in the first place. Is the fact that that data is coming in on an access port.
Before you go past that,
Sure.
quick question. There was a note that was in the Cisco stuff that said you can use interface range with
Yes,
the range, but if you're using a range, would that mean that same ID would go on to all of those?
correct. When you're in the range mode, that means you're configuring all of these ports the same way,
Same VLAN.
the same VLAN, yeah.
Why would you do that?
Because you don't want to, I mean, look how many ports there are. There can be up to 48. You don't want to do this 48 times. You know, if they're all in the same VLAN, like I said, they could be in 48 different VLANs. Then you have to do it that way. You know? So typically, enterprises will have a default running config. That's just a standard running config that is a baseline that they can just copy and paste into a terminal and load that switch or router up in a, you know, a baseline and then configure it from there. That would save a lot of time, especially if, you know, it's standard practice that ports 1 through 5 are VLAN 10, voice VLAN. If that's gonna be the case for every single switch in your enterprise, it's just a text file, copy and put it there. You know, you guys can do the same thing. Especially WebLive students, if like we were kind of talking about, we don't know how much time we're gonna need for these labs. So when you're over here and you gotta go, 5:30's coming up, we gotta get you out of here. We don't wanna be listening to routers and switches while we do lecture. You can save your running config and then do copy run start. And now there's another command we need to all be doing when we leave for the day. Erase VLAN.dat. Okay. We might have had to do that. I think we did have to do that in 140 once. No? Okay. Well, erase start and then erase VLAN.dat. That's the file. It was up here at one point.
We did.
We did?
Actually, yeah, it was.
Okay. I thought we did once. But hey,
Couldn't figure out the damn thing wouldn't work. So I reset it.
yeah, labs will be more interesting this time around. All right, so what's going on here? Oh, this is the slide that can cause some confusion. With about the whole IP network versus subnet versus VLAN thing. So this computer has 192.17.20.22. Now, just because it's in the 20th VLAN doesn't mean that the third octet has to be 20. Those are completely arbitrary values. They're not related. This could be 172.18.55. Whatever /24 if we wanted it to be. Okay. But this is pretty standard practice, just to helps keep everything right in your head. You know, that third octet will tell you what VLAN it's in. Now, what happens when you increase convenience? Do you decrease or increase security? Decrease security. Because now all it takes is one technician saying, oh yeah, the third octet, that's the VLAN. Oh, okay, that's useful information to somebody. Somebody nefarious. All right. So there's also a DHCP server on VLAN 20, because that's how it's getting an IP address automatically. Because it's IPv4. So pop question. Is a DHCP server required for DHCP v6? Can endpoints get IPv6 addresses without a server? Yes, they can. Is that stateful or stateless? Stateless. All right. Good job. Okay. An access port may only be assigned to one data VLAN. Yes, that is true. However, it may be assigned to one voice VLAN as well. So it's kind of like a trunk, but it's not really a trunk. Here's what that would look like. So you do the standard thing, you create them, and then you go in here, yep, access mode, but then there's this. MLS, quality of service, trust, cost of service. So cost of service is a value that results in the quality of the service. This is a similar concept as to something else we're going to learn in this class, administrative distance and metric. Okay, administrative distance and metric. So it's a similar concept. All right. Yep, so in addition to the data VLAN, we turn on quality of service, and then we have to give it a voice VLAN. Now notice, we don't say access VLAN, we say voice VLAN. So it's just one word difference. Could you do this one before that one? Sure. Got to do this one first. Got to do this command before you do that command. Just like how you have to do this command before you can do that command. And yeah, you don't need to know much beyond surface information. You can always go in there and do question marks to see what you would study in, you know, the rest of the CCNA classes. All right. So show VLAN summary, you're just gonna be given a bunch of numbers. Personally, I like show VLAN brief because it shows you more information. No, it's show interfaces. My hands know what to type. So play around with these commands. All right. Changing the membership. So if you want to, you know, take it out of a VLAN, no switch port access that VLAN. It's still in access mode. It's just not in that VLAN. It's placed back to its default position, which is VLAN 1. Okay. That is just one way. You don't, so like with some other commands, you don't need to put no in front of it and then do it again. You just do the same command, just the way that you want it to be now. So that's what that one's about. So you can do it both ways. Just realize that when you put no in front, it's going to go back to its default. Yep. So even though you remove a port from that VLAN, it doesn't mean that VLAN is deleted. That's a separate command. That's how you delete VLANs, no VLAN. And then that VLAN ID. Okay. Yeah, if you don't do this, I don't think it will be put, I think it will be put in VLAN 1, but the switch ports will be off, so they won't communicate. I believe that's the behavior. You could find out in less than a minute packet tracer though. I just won't do that right now. Delete flash VLAN.dat or delete VLAN.dat. So it depends on, most of our switches, it's this command right here, delete VLAN.dat. Okay, that's how you delete all VLANs. But that, that won't reflect until you reload the switch. Okay. Yeah, so there's no easy, simple factory defaults. Click button. No, you have to do two commands. Erase startup config. So erase start and then delete VLAN.dat. So those will be up on the board. Make sure to do that before you leave for the day on Wednesday. Yeah.
So it is delete, not erase.
Right, I was saying it wrong earlier.
Okay.
Yep. So just like we do with access ports, instead of switch port mode access, it's switch port mode start. And then don't forget to set the native VLAN. And then you would do this if you want to decide what to allow. So whatever you do not allow is denied. Okay. It is black and white. Allow or deny. But yeah. You'll do this a lot by the end of the class, by the end of these 8 weeks. All right. So this is an example. This is pretty similar to what you're going to be doing with the physical labs. You're gonna have a couple of VLANs here. And the IP addressing, I believe, is similar. Again, this is not ideal, but it's easy to remember. So this is an real world example of configuring, what is it, this interface. FA01 on switch 2. No, FA01 on switch 1. Switch 1, not switch 2. If we put it in trunk mode, we give it native VLAN, and then we tell it which VLANs it's allowed to send and receive. What VLANs would be allowed if we did not issue this line? All of them, all of them. Show interface. I think this is like the first time they actually do a shortened command in the PowerPoint.
Here's a FA, that's fast internet.
Right, correct. So what would be the maximum speed of an FA port? 10, 100 gigabit? Not gig, that would be gigabit Ethernet 01. Fast Ethernet is just a friendly term for 100 megabit. 100 base T. That's fast Ethernet. I know, it's.
Week fast.
Well, back then it was, you know, someday we're gonna have 100 gigabit ports right to our computer. Honestly, we should just, hopefully fiber becomes cheap enough by then. We'll see. All right. There's a lot in common with fiber infrastructure and railroads. Look it up. Has to do with economies of scale. It's a fun little story to go down about the early 2000s, Enron and all that. All right, let's get back on task. All right, what's going on here? We're doing some show commands. Oh, yeah. Interfaces, switch port. This is all of your 802.Q stuff. So it reminds you, hey, this is default behavior. When you see this, that should be a red flag in your brain. So did they assign this VLAN a friendly name? No, I don't think they did. It should show up as the name there, because this is just a number. This is a value. This is 12 bits. Okay, this is a lot. The name is a lot more than 12 bits. It takes a lot more bits to have, A through Z characters like that. All right.
I got a question. When we do the delete VLAN from that or whatever that is,
Delete VLAN .dat database.
you don't assign a exact, we need to put the VLAN ID.
No, when you delete the database, it deletes everything, all of the VLANs. So something happened, and this actually happened with some donated switches. You can erase the start of a config, but if you don't touch the VLAN, I can see all the VLANs that were configured, but just with a blank config. So Findlay Toyota donated a bunch of switches and I got to see what VLANs they used in the descriptions they gave them. Yeah, that was a security oops, you know? But you know, this was, you know, who cares what VLAN they were using in 2009? Okay. Sure, it's different. It's probably not actually. But, all right. So administratively set to trunk, it's either gonna be administratively or dynamically. But we'll get to DTP later. Operation, where does it say operation? Yep. Trunk. So you're either gonna see trunk or access there. Encapsulation.1Q, right, because there's different ways to encapsulate things. .1Q, which that's the command you'll use. .1Q, it's referring to 802.1Q. All VLANs created on this switch will pass traffic on this trunk. Right there. So out there in the world, are you gonna see highlighted things? Which is exactly what you're looking for, maybe with some AI Google glasses. That'd be cool. Oops. Okay, reset the trunk to defaults. Reset the default trunk settings with the no command. So where'd they do that? Oh, they don't, right. No switch port allowed. No switch port trunk allowed VLAN. So it's still going to be in trunk mode, but you're erasing the native VLAN. Yep, so it's back at default. And then, yeah, the fact that they're doing this implies that they did switch port trunk allowed VLAN 1-10, 1 through 10, comma 12, comma, yeah, commas and dashes. That's how you specify single and then ranges, stuff like that. Everything will be in the cloud and we'll just have to pay subscriptions for everything in 50 years. Yes.
What are types of encapsulation, or is it only the .1Q?
Right, yes, that's what the token ring and the FDDI stuff was about. Those are different layer 2 technologies. Do you guys know that BMW charges you a subscription for your heated seats and steering wheel? Yikes. Cheap either. It's not cheap, the subscription. I don't wanna know. All right, so here's what you would see if you did show interfaces, switch port, and it was in access mode. So it's shorter. Oh, no, they omitted it. Static access. Does that imply that we could do dynamic access? I think it does. All right, configure trunks, do all that. All right, DTP, dynamic trunking protocol. On by default, on most Cisco switches, dynamic auto may be turned off with the no negotiate command. So if you want to increase your security, you're gonna do this. Because anyone could walk in with a laptop, have some special software on there to where it's gonna talk and walk like a switch. And so that switch will think it's a switch and negotiate this trunk link. Now you just gave a perpetrator access to all of your VLANs. that that trunk is allowed to carry. So sometimes you want to not allow VLANs to get propagated. That's what we do to YC. We don't propagate the VLANs that we're using to them, and we don't accept anything besides VLAN 12 from the rest of YC. Well, there's a couple more than that, yeah. Only the VLANs that we want, right? You know? So we're using VLAN 999 for something. I'm sure VLAN 999 is also being used by the rest of YC for something else. So if we accidentally allowed them to communicate, that could be really bad. It's gonna make all the devices on that network see each other's traffic. Now they're gonna be different, probably different IP networks, so they're not gonna be able to ping each other, but they're gonna see all this traffic. Layer 2 traffic. All right, so I'm not gonna spend too much time on it, but you do need to understand what happens when a switch port is in dynamic auto, and then what happens when it's in auto versus dynamic auto and stuff like that. So there's a chart that you can create a box that has all that stuff in there. These are the different modes. So we know about trunk and access. Okay, but in the context of DTP, okay, this is what you get. I think they got a typo here. I don't think William's going to become a trunk link. He's not even there. He's making tea. Well, all right, so desirable. Will that create a link? Yes. If it's auto, will that create a link? Auto facing auto. Will that create a link? No, will not. Auto will only link if it's set to trunk, so statically, administratively, or if it's in desirable. Basically, desirable says, if you're willing to be a trunk, I'll be a trunk. But auto says, if you don't want to become a trunk, don't talk to me. You know? So if two desirables are looking at each other like, I could be a trunk. You want to be a trunk? Sure, let's be a trunk. But auto is mean about it.
Makes you a
Only,
trunk.
huh?
Makes you a trunk.
Say that again.
Makes you a trunk.
Auto will only automatically be a trunk if it's facing desirable.
So would auto be the best security wise?
Don't use DTP for best security.
Well, then wouldn't, oh, would trunk that bottom one, that would still be DTP?
No, permanent trunking mode and negotiates to convert the neighboring link into a trunk link.
'Cause it
Only,
still
okay,
sounds like
only if
back-
it's,
Negotiating, right?
if you do trunk, yeah, it's gonna be a trunk. If you do trunk auto, yes. Because if it's set to auto, it will automatically create a trunk if the other side is a trunk. So how does this work out? Expansions, okay? You go onto one switch and you set the ports that you know you want to be trunk links to auto. And then on the new switch, you set those trunks that you want to be trunks as trunk. And it will be created, you know, this could be months or years down the line. Yeah. This is not something that you usually need to do too often. But there's a really advanced concept that you guys don't need to worry about right now called software-defined networking. And basically that's having what will eventually be AI configure these things for you. You tell it, hey, I want this to happen, and then it will issue these commands. and make it happen. You know, so
I was gonna say, ChatGPT is already pretty good about that. Answers a lot of homework.
yeah, look, this isn't a writing class. I don't care how much you guys use AI and ChatGPT. It's like calculators. I'm not a teacher out there protesting calculators. Use technology. But use it to your advantage. Don't use it to your own detriment. You know? Stay on top of the AI. AI is gonna be on top of you. It's kind of the reality that we're looking towards. So here you go. I will screenshot this and put it in Discord. So yeah, this is basically what you need to stare at for a couple minutes. Stare at it for a couple minutes tomorrow and the day after that. And then right before the final two. Right, so if one side is dynamic auto and the other side is dynamic auto, well, you're not gonna do that. Dynamic auto basically, if something's connected to it, it's gonna put itself in an access mode. You don't do access to access. That would be a switch to switch that needs to be a trunk. Basically, this means you screwed up. We don't want limited connectivity, we need full connectivity. I mean, packets or frames will get through, but it's weird. It's weird. Misconfiguring trunks is also, you could lead to, you could be spraying a network with traffic that it's not supposed to get. Okay. And you might not know who or what is listening on that network at that time. Moving on. Verify DTP, show DTP. Best practice recommends that the interfaces are set to access or trunk and to turn off DTP. What did I tell you? Right here. Thanks, Cisco. Learn it to ignore it. All right, didn't do that. Honestly, we're not going to be working with DTP in physical labs, so I wouldn't mind if you skip that. But the more you know. All right, that's it. That's all we got. So let's go ahead and take a 10-minute break, and we're gonna get through as much of chapter 4 as we can. It's a bit smaller, so hopefully we'll get out of here before 9. All right, stop recording there.